here is the situation. I am attempting to make the sentences more wordy than they need to be. And this is on purpose. Last year, the AP Physics 1 exam had over 1,000 words you had to read. And that's just the FRQ section of the exam. It's a wordy exam. I know. It's coming back, I promise. See? The ghost in the room has allowed us to move on. So here's the situation. You throw a ball upward at 50 meters per second. Gravity slows the ball to a stop and reverses its direction. After 6 seconds, the ball is traveling downward at 10 meters per second. That's the situation. I've not said anything about what the ball is doing aside from that, or what I'm asking you to figure out. But that's the situation. Can you imagine that situation? Can you sketch a velocity graph that would match up with this situation? Please take a moment and try and do so. Okay, I'm kind of done waiting. I've drawn mine. Does yours look like mine? If not, let's consider what mine says. First, I did not label it thoroughly. Unlabeled graphs will net you this many points on the AP exam, so let's label thoroughly. Make sure it says velocity, and in parentheses, make sure it has the units. Otherwise, probably no credit. Make sure horizontal is time, and make sure again the units. Our graph should start from 0, always, and that's 0 in both directions. So this is 0 on the time axis and 0 on the velocity axis. I've counted up 5 even increments in order to get to a point where I'm going to place 50. So every one of those marks is 10. Fair enough? I'm saying all these things not because I think I want to insult your intelligence, but because I think of the 31 people, there are people in the room who don't know these things. Now, I have no reason other than me telling you to believe that this is a straight line, except we have talked about it. We have said that gravity is a constant, and the way in which gravity interacts with an object will be to change its velocity at a constant rate. So I assumed the velocity would be a straight line. So, because I assumed that, I picked a point here to start my line and a point here to end my line. I knew at 6 seconds I had a velocity of negative 10 meters per second. That's on the opposite side of the axes. I made an even increment in my head and drew a straight line to connect them. That is all I've done. Are there any questions about those choices that I made? Okay, this is going to be a part of your first test. If you can do these things, you're doing all right so far. If you can't do these things, you've got difficulty. I can move on. There are other things I think you should infer. Some of them you can do mathematically, some of them you can't. So these next couple of pieces are pieces I would like you to be able to infer from your graph. Again, I would encourage you to have your notes out for this. The slope of this line has meaning. We've already discussed the meaning. It's the rate at which the velocity changes, which we call the acceleration. So you should always consider the meaning and the value of the slope. When I found the slope, it was negative 10 minus 50 over 6. I took 2 points and divided by the time at the bottom. Basically, this should be 6 minus 0 if you'd like, which gave me negative 10 meters per second, which you could write as meters per second squared. That is the slope. And because I know the meaning of slope, I also know that this is the acceleration. On the exam, I am likely to ask you, what is the acceleration of the object? You should be able to get it from a graph or from the data or both. Any question about that? When did it stop? This is an important point. You should recognize anytime a graph goes over an axis that something important is happening. You should begin to learn to understand what that important thing means. In this graph, the object stopped. When did it stop? Can you figure it out from the data presented? Somebody's shaking their head. I think you all should be able to figure it out. Take a moment. I will choose one of you. Figure out when the object has stopped. Adequate and sufficient time has passed. So, I don't know. Hoth Square. You get to tell me.
5 seconds.
Raise your hand if you agree that 5 seconds is where the object has stopped. Perfect. With all those hands in the air, it's hard for me to have to ask how you knew that. But can I ask you anyways how you knew that?
Because the velocity is 0 at 5 seconds.
How'd you get the 5 part?
Well, like, because on the time graph, it's like increments of 1 second. So it's like 1 second down. Well, that's where.
It's okay. I'm not trying to put you on the spot here. 5 seconds is the right answer. I can think of 3 ways you could have found 5 seconds. So let me tell you the 3 ways I think, but I would like to hear from a student first. Jolie, what do you got?
Since the acceleration is negative 2 meters per second, you can buy 50. So if we start by 10, we get 5.
You can iterate the answer. You knew the acceleration is 10 meters per second per second. It's decreasing. We started at 50. So after the first second, how fast is it going? How many is that? 40. After the next second, how fast is it going? How many until you get to 0? There it is. That's as good a reason as any. I would like to show you another method. A method that I think is better for you. Especially better for your future. Fair enough? This is a straight line. So when I think y equals mx plus b, here I'm thinking v equals mt plus v naught. Or better yet, at plus v naught. Do you know why all of those letters are where they are? If not, I want to remind you. And I'm kind of done playing after this. Does everybody understand? This is on the vertical axis. Whatever's plotted there is here. Y equals mx plus b. This is on the horizontal axis. Whatever's plotted there should be here. The x part of y equals mx plus b. M is the slope. It represents the acceleration on this graph. That's why I put an A there. B is the y-intercept, which represents the initial velocity, the velocity at time 0. Now, we didn't use v with a little circle in this class, so that part you probably wouldn't know. I would have used, in this class, v with a little I. That's right, initial velocity. Sorry, I was still thinking AP Physics C. This v is final. The final velocity at the end of the time interval. So, I do think that anytime presented with a straight line graph, you should be able to figure out an equation that goes with that graph. That is the definition of Algebra 1. So, VF equals negative 10t plus 50. Any question about where I created that? That's just creepy. That's sus. I'm very, very concerned. All right, so the next part is the part that I think I need you to extrapolate, to bring together more than one piece to understand how you could get 5 from here. I asked for the, bless you. That's all you get though, 1. The next one I'm going to tell you to be quiet. Are you done? You need a Kleenex? Somebody else needed a Kleenex yesterday. I've strategically put the Kleenexes now down the row, so you have a short distance to travel to get Kleenexes. I thought so. If I want the time when the velocity is 0, I'm really asking you to figure out the 0 of this equation. That's Algebra 1 and Algebra 2, right? I know some of you have taken those classes, and some of you have even taken pre-calc now. That's what we're looking for you to be able to do. So the 0 of this equation is to put 0 in here and figure out the t, and I don't mean the rumors, the time at which the velocity is 0. And you're solving. This isn't particularly hard. Do we all see that this is going to be 5? I think so. This is another way to do it, but I like this way better. And the reason I like it better is it produces what I've called a motion equation, an equation that describes what this object does for all points in time. Okay, we doing all right so far? There's only one piece left, and then I'm going to ask you something mind-crushingly hard. Are you ready? I would like to know where the object is when it's stopped. Now, to figure that out, you need to remember something else we talked about yesterday. And so for those of you who remember, go ahead and work it out. For those of you who don't, suffer for just a minute while I prepare. If I want to know where it is, the first thing I probably should do is consider the displacement of the object, which is the area under the curve. I don't believe you have any other way to do this right now, although we talked about a way yesterday. Now, in order to do that, I must recognize the shape that's here. It is a triangle. And because it's a triangle, I can find the displacement by using 1/2 base times height. I needed to figure out this 5 before I could do this, because I needed to know that 5 for that part of the triangle. But this is the change in position in the first 5 seconds. It stops after 5 seconds. So 125 meters above where I am is where the object stopped. Any question about that? Ooh, 2 in a row. That sucks. So because that area is negative, meaning it's on the bottom part of the graph, the ball came back towards us. We can kind of figure out how far it came downwards, which just appears to be a paltry -5 meters. We good so far? That means after 6 seconds, the object is 120 meters above where I am, because I threw the ball. So here's what I'd like you to do. I would like for you to sketch a position versus time graph that describes this very same event. If I look at this graph, I will notice that the velocity is whatever this point is, and it's constantly changing. You ever understand? The velocity is constantly changing. Started at 50, and then it's at 40, and then at 30, then 20, then 10. You get where I'm going with this? If the velocity... Read me one of the homework questions. Let's tackle this sucker. I don't care which one. Pick the hardest one. They're all the same. None of them were hard? Excellent. Oh, yes, ma'am.
How the second change like that?
Perfect.
A ball is thrown vertically upward, leaving the ground at 40 meters per second. There is an acceleration of 10 meters per second. Why does that from gravity? How high does the ball go? And how long until the ball comes to rest?
Sounds like it's asking me those questions. Is that okay? Now, you're asked to make a sketch of this graph. Can you tell me how many seconds until it comes to rest? Look, you don't have to look at your paper. I want you to think about it. I threw it upwards at 40 meters per second. Is gravity slowing it down or speeding it up? We all agree it's slowing it down, and we know that it takes away 10 meters per second every second. So after 1 second, what's its speed? 30. After the next second, what's its speed? How many seconds until that's 0? 4. So my graph is probably going to look like this. Ooh, that's ugly. My sleeve caught on there. 44. Do I have to do much else? I mean, that's a graph. I should probably label it velocity, time, all that kind of garbage. But I want you to see this differently today, okay? Let's see this different. So I'm going to just not look at the graph at all. I want to look at what we know about this problem. First, we know from our studies a moment ago that these things tell us everything about the motion of the object. Would you agree? They include all the pieces. Do you realize that there are 5 pieces? 5 pieces. You might not have seen this, but every problem begins by giving you 3 of those 5 pieces. Every problem does. This one, it was subtle. The acceleration was 10 meters per second squared downwards. The initial velocity was 40 meters per second. The ball stopped. Final velocity 0. 3 pieces were given. You have 3 unknowns and 2 equations, each with 4 unknowns. Algebra, right? You can figure it all out with algebra. All right, tomorrow, understand why I'm doing it that way? So I know that the time portion of this graph will be the same because we're observing the same event. We're just displaying it differently. So this is still 6 seconds. And I could break it up into nice even increments. 1, 2, 3, 4, 5, 6. That's not particularly even, but that's going to be good enough for right now. I know that the object has a maximum displacement from the origin of 125 meters. So 25, 50, 75, 100, 125. So at 5 seconds, it's at 125. Is that okay? At 0 seconds, it's at the origin. And at 6 seconds, it's at 120, so that's not very much of a difference. 3 points. You have to connect these points. But the connection shouldn't be arbitrary. We know more about these points. What is the velocity at time 0? What's that? It's not 0. 50 meters per second. That's right. Remember, this is a position graph. And if I was looking at your notes, I hope it would tell me that the slope of a position graph is velocity, which means at this point right here, my graph has to have a slope of 50. That's pretty steep, wouldn't you agree? What's my velocity at 5 seconds? This point. Look at the velocity graph. It's 0, isn't it? Well, a slope of 0 is something that looks like this. Now, at 6 seconds, what's my velocity? It's right there on the previous graph. -10. My velocity is -10. So that suggests that my slope needs to be negative and shallow compared to 50, which is steep. And this is a very important question, and the answer to this question could help you on your test. Is the velocity ever constant anywhere in the 6 seconds? Does the velocity ever stay the same anywhere during those 6 seconds? Those of you shaking your head, always changing. This line never is a line. It's a curve. The slope is always changing. So I should have used some kind of curved line to connect it. A sketch. Everybody follow that so far? All right. Now this is a lot to take in. How we doing?